So sometimes it's useful and sometimes it's necessary to take a string and to split it up into other strings. And so in this brief presentation, I'm going to review what that means. So splitting a string up into pieces, how you do that depends upon you deciding where you want one piece to end and the next piece to begin. And we refer to the indication of where one piece ends and the other piece begins. It's usually a character. That character is called is known as a delimiter. So in a comma-separated list of numbers, the comma is the delimiter. Now, if the pieces are words and the delimiters are spaces, and you don't care how many spaces there are, you just care that there's delimiters and you can throw them away, then there's an easy way to do this. Right? So you've probably already seen in previous discussions, or if you've played with it, that when you read from a string, read from a stream into a string, that reads in a word. It discards leading spaces, reads characters until it sees a space and it stops. So basically built into streams is the notion that there is a delimiter, and those delimiters can be ignored. So I can say cin into my word. If my word's a string, it throws away any leading spaces and stops as soon as it finds a space. So if I've got a great big string with a bunch of words in it, it might be great to be able to read from that string instead of from a stream. And so the C++ library makes available to you something called a string stream. It can use all the stream stuff, but instead of having it read and write from standard in, or having it read and write from a file, have it read and write from a string. This is called a string stream. So we talked about once you create a file stream, all the stream operations work on it. Same thing here. Once you create a string stream, all the stream operators work on it. This can be very handy in certain cases. So here's an example. If I want to use string streams, I pound include s stream, string stream, right? And I have variables, very different types. There's an I string stream for an input string stream, and an O string stream for an output string stream. So an I string stream here, I've created one called myString, and I've initialized it with a string, the string help 10 times. Now if you look, the first piece of that input in the variable myString is a string with a delimiter at the end. The second thing happens to be an integer, and the third thing happens to be a string. So I can actually use, to get the first word out, myString greater than W1. Read from that string stream into a string. The second thing, read from that string stream into an integer. So it'll convert the string 10 into an integer and stick it in ival. And same thing with the last word. You say myString into W2. So when this is done, W1 contains the string help, ival contains the integer 10, and myString contains the string times. Now, of course, this only works if the types match, right? So if you say myString greater than ival, extract from the stream into an integer, and the next thing, the thing that you're up to in the stream isn't an integer, well, then you're not going to be able to read it. That's going to fail. But if you just want to read a whole bunch of over and over and over again, you can do this. Have a loop that repeatedly reads from myString, the string stream, into the string W1, and then prints it out. So this breaks a long string up into a bunch of words, delimited by spaces, throws the delimiters away, and prints out each word on a line by itself. That can be handy. Now, sometimes it's useful to do things the other way, right? Here, I'm doing a similar thing. I'm pound including S stream, but instead of an I string stream for input, I'm doing an O string stream for output, right? So notice that I've created this thing called OS and there's nothing in it, right? And I use operator less than. I write the string there are to it, and I write the integer 101 to it, and then I write the string Dalmatians to it. Great. So then I can take that variable and use its .stir method to take the string that has been assembled in that string stream. So here I have put there are, and the string there are, the integer 101 and the string Dalmatians into OS. os.stir will be equal to there are 101 Dalmatians. So sometimes it's useful to combine a whole bunch of different things into a single stream and then read it all. There it is. So this is a handy thing to have in your bag of tricks, particularly if you've got a whole bunch of things that you need to print out, and ultimately you want to just print out a single string. Take all the different things, combine them into a string stream, and then use os.stir to actually print it out.